Hello. Last week we discussed placing fittings, and I've shown you a couple of tricks on how to quickly place fittings. And as I promised then, today I will show you how to place pipe clips, pipe hangers. I've got a really nice trick on how to place these. Why is this so important? Why is this so different? Because I found a way of placing these as regular fittings in tube and pipe, but as you'll see here, the pipe is not interrupted, so the bill of material will still report a full-length pipe, and yet you'll be able to drop these as regular fittings, choosing orientation and distance, and just like a regular fitting. So as soon as you place it, you'll get the orientation option, and you can control the distance. This is still a one single solid pipe, full-length pipe, but if you go inside the root, you'll see a node's been created there, and you can control the position of this clip with this node. So although we're inserting a fitting, the pipe will not be interrupted. Now before I show you how to alter this, I'll show you how I created these clips. I've downloaded the catalog from George Fisher, but just like any other catalog, it doesn't have all the information, so I've downloaded the step files as well in order to create my iPart. And I've used a nice little tool called Feature Recognition, which is on the Autodesk Exchange app. Unfortunately, it's on subscription only, but hopefully you'll have someone with a subscription that can borrow you this. So as soon as you open a dump file, step SAT or something, it will ask you if you want to recognize features, and you can play with starting to identify fillets and extrusions and radius and holes and so on and so on. You don't have to use this. I just wanted to play with it and see how it's working. As you can see, it took a while until I realized how to use it properly, like with the hole, which you cannot recognize it with the hole feature, or I couldn't. I've used revolved cut, so I've got it as a revolved cut. But you can create this manually, trace the outline, or as soon as you have it as a dump part, you can project all the edges and construct it yourself and dimension it. I just want to show you how I've done it. I still need to remove the hole there, and then there's only one feature, which is the extrusion. As you go out, it'll create all these features for you, and actually I don't need that hole at the top. I'm going to delete it. This is a simplified version that George Fisher has provided. It doesn't have all the connecting points, so you can do it manually if you have to, but unfortunately the catalog didn't provide enough information, so I had to manually open each and every size in order to create my table. I needed a table, I needed an iPart table, and I needed to publish it to Content Center so I can easily drop onto my roots and be able to do change size or change fitting diameter. This is the Excel file of the iPart. This is how it looks at the end, as soon as I've added all the information, all the missing dimensions. And you need that if you're gonna have different size pipes and you want to place it on different diameters like I have. Got some really big sizes like the 2-inch drain there. So what's so special about outdooring this? Well, if you wanted to be able to place it like that, you need to outdoor it as a branch fitting. It's a weird one, and leave out the cut mating pipe out. So you've got a mating point and you have a pipe access and you outdoor it as a branch fitting, and then you'll be able to drop it in without having the pipe interrupted. Like any of these. Let's place a big one. I'll show you how the mating point. That's where the mating point gets connected to the pipe. Yeah. Looks pretty good. I'm just showing you that how the connection works. So you outdoor it as a branch fitting, and you leave out the cut mating pipe out. If you don't know how to outdoor branch fittings, take a look at my blog. I've got a really nice one, when a special fitting for a flow meter from a George Fisher flow meter. So look at the outdooring branch fittings. You've got all the details in there, but I have the cut mating pipe option on in there because we actually want to cut the pipe so that the flow meter can go through. Yeah. But in our case, on the pipe clips, we don't want that. We want the pipe to be all completed. There's a short video as well. My connection is really slow. It'll show you how to outdoor the branch fitting. No, it started. Okay. So take a look at the video, take a look at the post if you don't know how to outdoor branch fittings. The pipe is not interrupted. It's one solid complete pipe. But if you look at the root has nodes for every pipe clip that you insert, and this is good because we can control the position of these nodes with dimensions. You don't have to, but I like to control the position. Say like in this case here, that's a pipe clip. So I have an elbow or a T which takes the same space over there, and then I have a clip over there, and then a gap in between. So I can control these. I import my parameters all the time depending on the root size. So I usually just type in E plus CP plus GP, meaning elbow plus gap plus pipe clip, just so that it looks nice and it helps you on confined spaces. I've got two parameters. I've got a clip height and a clip width. The clip height is used to dimension from the wall, just so that it looks like the clip is sitting on the wall. So you can increment this by whatever pipe clip thickness are available. They come in 20 mil in this case. I didn't bother to put a parameter. I can just easily type in 20, 40 or whatever I need. But so I import parameters for all the sizes, different size pipe, different size root, and different size elements. I have these as XMLs, and I import them as soon as I've started the route. It just helps me laying them out easily, and to have constant gaps, constant distances. It looks neat, it looks nice. So sometimes in the authoring process, you define your mating point and your pipe axis, and you click OK, and you've got success authoring. But if you look at the author information again, you will see that the pipe axis goes through the pipe mating point, which is wrong. This is a bug. See, if I'm trying to declare the mating point, it comes with an error. Don't let this stop you. Just define your point and your axis again, author it, and publish it to Content Center. It will work. This is a bug. As soon as you look at it, it just comes in with wrong authoring information. Okay, so, but what about vibration clamps? You know, the ones that you mount on a stud with a couple of nuts. These are different. I mean, these have different length. How do we deal with these? These we cannot publish to Content Center because they have custom length, or I have them as the option to have the nut or not, because I may be welding this straight to the frame. I've downloaded these off the internet. I didn't build these, I didn't design them. So all I've done is I added the stud and the nuts, and I'll show you how to deal with these, because Inventor doesn't support this directly. You can insert these in two ways. You can create it an iLogic part, or create it as an iPart. What's an iLogic part? An iLogic part is a part that has custom parameters defined. So when you place it, it asks for those custom parameters. I have my stud length, and I have the plate thickness, and also if to give me the nuts, mounting by nuts option, or just plain welded to the frame. This is an iLogic, and I'm showing you both because I'll show you the limitations. I've tried this in every possible way. So this is authored, yeah. But unfortunately they don't work. They don't work the way they are. So the other option would be to do it as an iPart. What's an iPart? An iPart is the part that has a table, and I have the stud length and the plate thickness defined as custom parameter column, meaning I can have different lengths all the time. So it'll create a new instance for every length, every possible length and plate thickness that I have. Unfortunately, when it creates a new instance in the table, it actually derives the main part, and deriving the main part loses the authoring information as well as the mating point and the axis. So that's not a viable option. So we cannot use an iPart. I'm just going to try and place it. As soon as you drop it, it doesn't ask you for the stud length, it doesn't ask you for the plate thickness, so this is not working. Let's try it as an iLogic. This is not working. I'm just showing this because I've tried every possible way. I have two solutions. One involves buying the M extension, formerly M extension, called MF Manager now, and the other I'll show you in a second. So this is an iLogic part. I have declared my stud length, I have declared pipe thickness, and if to show me the nuts or not. What do you mean by showing the nuts? If I'll say no, just to show you what it does, it just gives me the stud, meaning it'll be welded, so it's not gonna bring in the nuts. So this should work, except that it doesn't for outward fittings, doing pipe fittings. So if I'm trying to place it, it's not working. But if I'll try and place iLogic component, it looks like it's gonna work, because it asks me for the mounting distance and the plate thickness. But as soon as you click OK, for some reason, this is a bug, it just comes back with choose the fitting that you want to place. I've already defined the one that I want to place, and I've customized it. So instead of just creating the instance based on your custom length, it just comes back to choose the one that you want to, the fitting that you want to place. So this is clearly a bug. Hopefully they'll fix it in the next Inventor releases. But I'll show you the other two options. Let me just let me find one. I have a stainless pipe there. Let's just try and let me measure and try and place one. So I'll try and place one there. The other option would be place from libraries. This is not in your Inventor menu. This is part of the multi-file manager. This is an add-on. It used to be called Extension. It's a very useful add-on, and it also creates another entry in the assembly place drop-down. It's got very useful commands like resolve references, or clone, or part numbering, or project integrity check, or rename. Project integrity check, well, this is, sorry, assembly integrity check, which checks for duplicates, file name, duplicate part numbers, missing references, and so on and so on. If you don't know what the multi-file manager is, well, go to my blog and search for an extension. This is what it used to be called. It's been tried and tested on Inventor 2016, and it's working. Unfortunately, this involves some money. There's a cost, but when you let me just show you how this works. When you choose place from libraries, let's change the interface. That's a bit dark there. I have mine on random just so I don't get bored. Let me choose something more visible. Again, place from libraries. And it comes up with an interface. This is good for searching also. I have searched anything in the name, so all the files, just parts, don't search subfolders, and this is where I want him to search. That's a list of the most common used places, and that's the browse. Let's search. So I have a list of all the parts. Some of them, the one with the table is an I part, and the rest are just iLogic components. You can see the FX in there. And I have two options. I can insert locally, which is locally to the assembly, next to the assembly, where the assembly is located, or insert, which is gonna insert it in the library. Let me just show you. So where this part is, it's gonna create a folder, create my instance there, generate my instance there, and allow me to place it like a regular fitting. Same as placing iLogin component, it comes up with the custom parameter, the key parameter, sorry, that I can change. So I've defined it. As soon as I click place, it creates the file and it gives me the option to place it. So now I can place it as a fitting, as a regular fitting. Just drop it into the pipe, change rotation, and it's how Inventor should work. This is how Inventor should place iLogin fittings, tube and pipe fittings. So if you look inside the root, you'll see the node. Unfortunately, whenever it inserts the node, it creates a mess. That dimension was never needed. It removed the constraint there, a perpendicular constraint. That should just fully constrain my sketch. And now I can position the node, the position of the clamp with a dimension. So you probably know this, but you can dimension it in the place process. You don't have to dimension it like I do. But as soon as you place it, you can activate point snap and use a reference to position it. So it's like you drop it in and then you right click and activate point snap and choose a face. Just hold your mouse there and type a distance. So if I'm typing 100, the point, the node will be 100 from that face. It will not dimension it, but if you measure, it is 100 from that face. You will not have a dimension on the root, but it'll actually be positioned this way. And if you change orientation, I need to be in the run. Yeah. If you when you change orientation, you can also change the distance, the placing distance. So again, hold your mouse, activate point snap, hold your mouse, and then 150, 200. Or choose any face, anything that's where you can hold your mouse over. Yeah. So this is one way to place it really quick and then dimension it in the root. If you want to, maybe you don't want to dimension it. I would suggest that you dimension it. Otherwise, you will not have fully constrained sketches, and as you know, they can go crazy. You can have overlapping geometry going into root violation. So I would suggest to dimension it afterward. Just go inside the root and put a dimension. So place, don't forget, let's just simulate, say that this is sitting on the floor. Yeah? So we'll turn it and then right in the process, point snap, choose a face and type a dimension. What am I doing wrong? Oh, I know what I'm doing wrong. I'll show you in a second. Let me just place this and I'll show you in a second what's wrong with that. So point snap, you rotate it to simulate it as this pipe sitting on the floor. Let's go 90 and then activate point snap and just say 10 mil from that face, and this way you have it nicely arranged right in the place process. Now what's wrong with this? Because this was inserted already, so meaning the node existed, we were just trying to redefine its position. We wanted to position this node over that line, over the next line. I'm not sure if you can see this. So we would end up with two overlapping lines, which is not possible. The root will go into violation mode. I hope you understand this. Now, what's the other option? I know this, I'm not ready to spend any money, or you cannot get your hands on this. What's the next option? The next option would be to start another Inventor session and disable Tube and Pipe add-on. So take it off. And then let's see the other two options again. Open a test assembly, like I do. And then let's try and place the iLogic component and the I part. Let's try with, let me just show you why the I part is not working. Because when you place an I part, it actually derives the main component. And in the derive process, it loses all the authoring information, and it loses the geometry that we defined for authoring, like the connection point and the pipe axis. So, not sure if you can see there's no mating point and there's no pipe axis. This is just a derived component from the main part, the main I part. So again, the option would be to place as iLogic component. Let's remove this. And then you can choose the stud length and the plate thickness, and it creates the part for you. And it's been author. I cannot show you the author information because I've disabled the Tube and Pipe add-on. But so I don't think this is a good option, because you'll have to rename the file probably. Otherwise, you'll have duplicate file names on disk or in Vault, and it also creates the file wherever the assembly is where you're placing it. So I don't think this is a viable option, but it is working. So I'm showing it to you anyway, right? So how do you get this into your assembly? Well, let's try and activate Tube and Pipe, which you can't. You need to shut down this session. You have open files. So you copy the file path, and then you switch to the Inventor that has Tube and Pipe add-on enabled, and then you try and find the part that you generated in the other session. I'm not saying you're going to use this. I'm just showing you that it's possible. I think this is a bug, and hopefully Autodesk will fix this. We need to be able to place the iLogic components, Tube and Pipe authored iLogic components. So see, this is working. So you can place it, but you have to switch in between two sessions. Plus, you have to rename it. You have to bring it over in next to your assembly on disk, or put it in library somewhere. So I think this is not a viable option. But remember, disable Tube and Pipe, yeah, and you'll be able to generate this as an iLogic component. Or use you have a license, use the multifier manager. Let's try with a plain stud. So you can generate this, and again, copy the path, switch over, place fitting, browse for it, and so on and so on. Or you can quite easily use the place from libraries, same thing, and just say insert because you want to insert it in the library, wherever that is. And it creates the file and it allows you to place it in the same time as a tube and pipe authored fitting. Let's just try again without the nuts, just a plain stud, welded stud. And this is how you do pipe clips, pipe hangers, iLogic or not. So I hope you learned something new, something that you'll find useful, and check the blog. Till next time, bye bye.